Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this December month lecture series, we are discussing about frequency response analysis topics. Here, I am going to discuss about the polar plot. Why do we need polar plot? In previous video, we have discussed about Bode plot to analyze the stability of a particular control system with the help of phase crossover frequency, gain crossover frequency, phase margin as well as gain margin. Now we are going to discuss about the polar plot in frequency response analysis. Okay. First of all, polar plot is a plot which can be drawn between magnitude and phase. Here, the magnitudes are represented by normal values only. The polar form of g of j omega h of j omega is g of j omega h of j omega is equal to magnitude of g of j omega h of j omega and angle of g of j omega and h of j omega. Here, the polar plot is a plot which can be drawn between magnitude and phase angle of g of j omega and h of j omega by varying omega from 0 to infinity. Okay. Here, the polar plot is drawn on the polar sheet, which is the form of a graph, and the graph consists of concentric circles and radial lines. Actually, a Bode plot we can represent or we can draw the Bode plot using semilog graph. But polar plot case is different. Here we use a separate polar plot graph is used here. It consists of concentric circles and radial lines. These concentric circles on the polar sheet graph represent the magnitude and the radial lines represent phase angles. Each point on the graph displays information about the magnitude and phase angle. Actually, the Bode plot is represented in semilog graph. In that, we can draw the gain plot, phase plot, and then we'll calculate and we have estimated phase margin, gain crossover frequency, phase crossover frequency using some kind of formulas and calculations. And in this case, we use separate polar sheet which consists of concentric circles and radial lines. Concentric circles for magnitude and radial lines for phase angle. Remember that each point on the graph displays the information about the magnitude and the phase angle. Okay. Here, the most important thing is type and order of system, which is used to measure the stability of a control system. Here, the type of a system in the polar plot determines the quadrant at which the polar plot starts. The order of the system in the polar plot determines the quadrant at which the polar plot ends. Okay. See here, in the right hand side, start of type 0 system, and in the upper side anticlockwise we have start of type 3 system, in the left side start of type 2 system, and we have start of type 1 system 0, 1, 0, 1, 2 and 3 in clockwise. Start of type 0, start of type 1, type 2 and type 3. See here. Here we have end of order 1 system, end of order 2, end of third order and end of fourth order. Type of system means in polar plot it determines the quadrant at which the polar plot starts. Order of the system is in the polar plot determines the quadrant at which the polar plot ends. Okay. What are the rules for drawing polar plot? How do we differentiate this polar plot from Bode plot? The first thing is same, common. Substitute S equal to j omega in the open loop transfer function, because we are using frequency response analysis here. So we need to substitute S equal to j omega and write the expressions for magnitude and the phase plot of g of j omega, g of j omega and h of j omega. Find the starting magnitude and the phase of g of j omega, h of j omega by substituting omega equal to 0. So the polar plot starts with this magnitude and the phase angle. Find the ending magnitude and the phase of g of j omega, h of j omega by substituting omega equal to infinity. So the polar plot ends with this magnitude and phase angle. Check whether the polar plot intersects the real axis by making the imaginary term g of j omega, h of j omega equal to 0 and find the values of omega. Next thing is, check whether the polar plot intersects the imaginary axis by making the real term g of j omega, h of j omega equal to 0 and find the values of omega. Drawing the polar plot more clearly, find the magnitude and phase of g of j omega, h of j omega by considering the other values of omega. Here omega is your frequency and we need to draw this plot in imaginary as well as in real axis. With the help of concentric circles and radial lines, we can draw the magnitude as well as phase to analyze the stability of a control system. Thank you.